Hello everyone, welcome back again to our channel Code Circuit. So in today's video, we'll be solving one more LeetCode question, which is winner of the circular game. Guys, this is a application of recursion, so we'll be solving it today. And if you guys have not subscribed to our channel and if you are new to the channel, I'm requesting all of you to please subscribe and share our videos with your friends and family. And if you really like this content that we are bringing to you, please make sure you hit the bell icon and also share it with all of your friends so that everyone gets benefited by these videos. Okay, so as I said, today's topic is lead code question, and let me just show you that question here. You can see here the question is find the winner of the circular game. Guys, I will give you the link in the description and also in the I button. You can go and have a look at that. So it has been asked in lots of interviews, and it is an application of recursion actually. Okay, so find the winner of the circular game. Okay, so you can go through it and read it, pause the video and you can just read it and understand. And in the meantime, I will also explain you. So here you can see it says find winner and it has two parameters, int n and int k. Okay, so let us just go to our board and try to understand better about it. Okay, so here we see that we have a value given n equal to 5 and we have another value given k equal to 2. Okay, so in this first sample test case, we have these two values, the value of n is 5 and the value of k is 2. So what it means is we have 5 friends who are actually sitting in a circle and we have to count k. Okay, this count is given, so let me take a different color and we have to start counting in clockwise direction only. Okay, something like this. Say k equal to 1, then we have k equal to 2. As soon as you get the count k equal to 2, you have to eliminate that person from the circle. Okay, so then the next count will start from here. So k equal to 1, k equal to 2. So this is gone. And finally, you can see the k will start from here, right? K equal to 1. So this is k equal to 2. This one is gone. And now it starts from here. So here it is k equal to 1 and k equal to 2. So in the end, we are left with 3. So for n equal to 5, the winner is 3. Okay, makes sense. So you understood this. So similarly, this is one test case. Let us go back and see the other test case and understand that. Here, see, they have given you the diagram. 1, 2, 2 is gone. Then it starts from 3, 3, 4, 4 is gone. Then it starts from 5, 1, 2, 1 is gone. Then it starts from 3, 3, 5. Finally, 3 is the winner. And the condition here is like this. See, at the end, whoever is left behind in the circle is the winner. So if there is only one person in the circle, then that person is the winner. That is the condition. Okay, let's see the other test case also. N equal to 6, k equal to 5. Okay, so in that case, let's just try to understand this. The second test case. Here we have n equal to 6 and we have k equal to 5. Okay, so let's try to write this. 1, 2, 3, 4, 5 and 6. And let's take a different color and say 1, 2, 3, 4, 5. K count is 5 here. Okay, in 5 counts this one is eliminated, then we'll start from here, right? So 1, 2, 3, 4, 5. 4 is gone, so it will start from 6 again. So 1, 2, 3, 4, 5 gone. 1, 2, 3, again 4 and then 5, so 2 is gone. So 1, 2, 3, 4, 5. So here if I see, I can see that 1 is the winner. Let's verify here. So you can see the output is 1 and the friend 1 is the winner, right? Okay, so this is our logic here. So let's go ahead with the first test case and try to analyze this. Okay, so guys, the important thing about this question is you have to find a relation between n and the w. Okay, so in the test case given, we saw that if the number of friends in the circle is 1, the winner is 1, right? Because if there is only one person, we cannot even count k, right? The k count given was 2 in the first test case. So here we cannot count k. So ultimately, this one is the winner. So for 2, if I take 1 and 2, Obviously 1, 2. 2 is gone. So for 2 also 1 is the winner. Correct? If there are 3 people, 1, 2, 3, then you can see 1, 2, 2 is gone. Then 1, 2. Obviously for n equal to 3, 3 is the winner. Yes. Then let's take one more. Say 1, 2, 3, and 4. Let's verify this one. 1, 2, gone. 1, 2, gone. Then 1, 2. Sorry, 2 will not come here. 2 will come here. So this is gone. Yes. For 4, 1 is the winner. And for the fifth one, they have already given the output. We have already seen that, right? For 5, it is 3. Okay. And here, this is very important, guys. This table that you see here is very important. Now you have to try to find a pattern so that we can actually understand how it is working, right? Can you guys pause the video and try to understand if there is any pattern involved in this table that I've given you, N and W? So practically speaking, you might be thinking something like this. See, for even numbers, if you observe, you have 1 as the winner, right? And for odd numbers, if you see here 3 and 5, then you are getting 3 and 3 as the winner, and 1 being an exception here, right? For 1 it is 1 only, obviously, because that can be taken in a different parameter. But if you think like that, what I said, even numbers 1 is the winner and odd numbers 3 is the winner. And that is what is our criteria, right? See here, for this 2 1 is the winner, and for this 2 3 is the winner, correct? But the problem is, if you take that as a pattern and try to do it for 6, let's verify what we are getting. Okay, so 1, 2, 3, 4, 5, and 6. So here it is 1, 2, gone. 1, 2, gone. 1, 2, this is gone. Again say 1 and 2, gone. And finally we are left out with this 1 and 2. So guys, see here, this is the problem in this question. Now 5 is the winner. So for 6, which is an even number, we have 5 as the winner. So the logic that we saw here, for even numbers, see this 2, 1, 4, 1. Now we are getting 6 as 5. So the pattern that we were thinking about is not possible here. That is the actual catch or the trick in this question. We cannot actually find out any pattern here. So that's why this question has to be solved by a recursive algo. Okay. So what we can do is, I will just show you something here. Okay. We will try to figure it out like this. Let's do one thing. So as I said, for 1, obviously 1 is the winner. And were we able to count the value of k? No. Correct. So let's try to do something like this. I'm trying to find a solution like this. I'm saying solve of n comma k. Is it somewhere related to solve of n minus 1 comma k? Because in case of recursion, we already know that n always tends to go to n minus 1, right? That's why we come backwards. Like if you have learnt about factorial or any other Fibonacci series, then you see that from n we go to n minus 1, n minus 2, and so on, right? That is how our recursive algo works. So here what we have to do is we have to check something like this. So if I say solve of 2 comma k, is it somewhere related to solve of 1 comma k? Can we verify this? So the answer for 2 comma k was 1 only, right? And if you see properly, for 1 also it was 1 only. If I go back to this table here, then you can see that for 2 also it was 1 and for 1 also it was 1, right? So they are similar. So I am getting a relation here. So let's try for the other numbers. Say if I say solve of 3 comma k, is it somewhere related to solve of 2 comma k? If this is true, then obviously we can find a very good relation here. Okay, so let's do this. So 3 comma k, I saw that the answer was 3, but 2 comma k, the answer is 1. So these two are not at all related, right? What I can do is I can add k here. Yes. What is the value of k? The k value given is 2, right? So 1 plus 2 becomes 3. Now this 3 is equivalent to this 3, right? So they are related. I will tell you why I'm adding the k. Don't worry about that. Let's try to relate the other ones. Then we will try to analyze this. Okay. So now s of 4 comma k, is it somewhere related to s of 3 comma k. So for 4 k, you saw that the answer was 1, right? And for 3 k, the answer was 3. But we also added k, right? So if I add k here, 3 plus 2 becomes 5, right? So do you think it is practically possible if there are 4 friends in the circle? Am I anyhow getting 5 as the answer? Just think about that. There are only 4 friends in the circle. Can I ever get 5 as the answer? Not possible, right? So if your answer is going beyond the given value of n, then you have to do modulus of n. Okay, that means 5 modulus n becomes, n is 4, right? This becomes 1. Now you can see this 1 is actually related to this one. Make sense? And let's verify for the last one as well. Okay, so we also saw that solve of 6 comma k, is it related to solve of 5 comma k? So 6 comma k value is what? We saw that it was 5, right? And for 5 comma k, what is the value? Let me just confirm that once again from the table. Yeah, 6 comma k was 5. So let's verify once again. And the 5 comma k value was how much? 3, right? Correct. Plus we were adding k value is 2. So ultimately this is also 5, right? See? So it's working fine. So ultimately we have tried and found out a relation between the nth value and the n minus 1 value. Correct? So if you try to figure out the formula, this can be something like this, right? Solve of n comma k tends to solve of n minus 1 comma k, plus we were adding the k value. And if your answer is going beyond, then what were we doing? We were doing modulus of n. Now in your mind you will be having a very important question: why are you adding this k and why are you doing this modulus of n? Right now I am explaining this, but how will you understand the same thing when you are actually attending any interview, right? That will be a very big question in your mind. Right now I'm telling you the solution, but how do you figure out when you have to do this kind of things? Let me just explain that thing to you. So suppose I'm saying I have only one person in our circle. Are you able to count k? Just think practically. K is 2, 1 2 I cannot even count, right? I cannot touch my head and say 1 and 2 together. I need one more person to do that. So when the value of n is 1, k count is 0, we cannot count. Similarly, if I put one more person, I can count k equal to 1, k equal to 2, one time only, right? So n equal to 2 means I can count k one time. Similarly, if I have 1, 2, 3, now if you observe 1, 2, this is one count of k, again 1, 2, this is second count of k. So ultimately, the n value increases, the count of k also keeps on increasing gradually. That's why I am repeatedly adding this k one by one. But for the first time, because we did not have to count k, the value of k was 0. And that's why we got the answer as 1 only. Correct? For the other cases, we are doing this. Now I hope you have understood why every time I'm adding this k value in the equation. Make sense? Now, similarly, let us see why I am adding mod of n also. Okay. So, just try to understand this. Suppose I have uh, 0 modulus of 5. What is the answer? It is 0 only. Now, if I have 1 modulus of 5, it is 1. 2 modulus of 5, it is 2. 3 mod 5 is 3. And go on. If you write 5 mod 5, what is the answer? It is 5 mod 5, 0. Correct? No remainder, ultimately 0. And then if you see properly, if I write 6 modulus of 5, what is the answer? 1. Again, 7 mod 5 will give you 2. 8 mod 5 will give you 3. Correct? And going on, if you say 10 modulus of 5, you will get 0 as the answer, because 10 is directly divisible by 5. There is no remainder. So if you observe, a cycle is getting repeated: 0 1 2 3 4 5 0, again 1 2 3 4 5 6 0. Understood? So what is this actually? So just remember this: whenever you are getting a competitive coding question where you have a time limit of say 5 minutes or 10 minutes, don't just mess up your mind with DSA concepts and all. Just think about recursion. It will help you to solve any equation very easily and very fast. Okay, only if you have more time, half an hour or something, then you should go for any other algos. Guys, this question can be solved with uh, circular linked list also, but it will be a very messy thing and you have to write a very long code. That's why I'm giving you this easy algo. Okay, I hope you understood this. Now that's why you can see, just remember one thing: if somewhere in the question they have given that the first and the last numbers or something are connected, then always remember your answer will be coming through modulus only. Okay, and here it is 0 modulo. You can see we're starting from 0, right? So in that sense we can add 1 to the answer every time. I will tell you what I'm meaning by that. So finally I have arrived to a solution which is like this: our solve of n comma k is equal to solve of n minus 1 comma k plus every time we are adding a k, and if your answer is going beyond, then we are doing modulus of n. So this is your final formula. Okay, and you always know that when n tends to n minus 1, this is a algo called recursion. Okay, guys, this is a very important application of recursion. I hope you have understood this. Now, based on this formula, let's go to our LeetCode problem and try to solve that. Okay, if you have any doubts, please post your doubts in the comment section. I'll be very happy to clarify them. Okay, so let's go back to our LeetCode question. So here, always remember, just try to separate your logic from the main function or the main code that you are writing. Okay, so what I will do, I will just say solve. Let me just maximize the size a bit. Okay, so here what I will do, I will take n comma k as the variables, and as I said, guys, let's talk about the base case first. Okay, the base case is, suppose there is only one person in the circle, then what will you do? Obviously one is the winner, there is only one person. So I will say if n equal to 1, that means if there is only one person, then I will return. Because I told you about 0 modulo, right? Let me return 0, and from the answer we can do one thing: every time we can add 1 1 1. Okay, that can be done every time. Otherwise we will use our recursive call to the same function. Okay, return, I will say solve of n minus 1 comma k plus we were adding the k, and the answer going beyond, what will you do? You will do modulus of n. That's all. This is your logic. And now in my function, the find winner function, I will take the winner as a function call to the solve function where I will pass my n comma k values. And as I said, if we are passing 1 as the value to that function, it will return 0, right? So every time I have to add a 1 here. Okay, and finally what you can do is you can return the winner. That's it, guys. See, if you understand the logic, writing the code is very simple. So now let us try to run this and see if it is working or not really, because only by telling this we cannot understand. We have to run this and check. So running this, yeah, you can see it has been accepted. Okay, so now let me just submit and see if it is working or not. Yeah, guys, you can see here submitted, and you can see it's awesome, right? Understood? So this is how you can solve easily a competitive question without any difficult data structures. You can just use a recursive algo to solve it very easily within the given time. Okay, so hope you have understood this, guys. If you like this video, please don't forget to like and share our videos with your friends and family. And also, if you are new to the channel, please subscribe to our channel and hit the bell icon, because that is the least thing that you can do to motivate us to create more content like this. Okay, so thanks for watching, guys. Till the next time, this is Saurabh signing off. Bye bye and happy learning. Thank you.